pictures are okay. And in case you have any trouble, you talk to me, sir, I am stuck up, my mail is not working properly, but that request should come before the close of the examination. It may happen that when you are just uploading, suddenly you see that your net is not working. This thing can happen, but in that case, you should send the request through mail or through SMS before the completion of the examination. So these are some of the minimum steps we should follow. We all appreciate that what can happen under the given circumstances, and it can happen to me as well. So that's why, I mean, in case I cannot upload because of my problem in the set, Shubir will upload. So from your viewpoint, there should not be any trouble. And please do not forget to send the answer script to both. Please don't send to only one teacher, because this will be jointly checked. Otherwise, it will be a lot of trouble for us to find out, who is in my group and who is in others group. And okay, these are some of the things. And fine. So can I just start or should wait for 1 or 2 minutes? Okay. So first you give your attendance here. I just write. Okay. I sent you 2 PPTs, and I will talk on one of them. The second one, uh, there is a slight change, and I will send this one today after I'm done. So let me. Can you see it? Okay, fine. Here I go. So this is the topic, and within this, under this topic, I should say, we will also discuss construction of dams, tunnels, and other things. And of course, it is written that it is for ductile deformation, but I will be jumping from ductile to ductile because nature is just like that. And before I show you the next slide, I just like to share a thought of mine that rock mechanics in real life does not exist as a standalone subject. Real life means when you are thinking of constructing something, when you are thinking do something to prevent the disaster, when you have to face this kind of natural situation and you have to make construction or to think about the stability of the construction, rock mechanics alone cannot help. Rock mechanics should be taught alongside the fluid mechanics. Otherwise, rock mechanics for engineering construction and even for art sciences has very limited value. So that's why in the first few classes, I discussed some of the fluid properties, and then I switched over to mostly the solid materials, rocks and minerals. Today also I will be discussing dominantly on the properties of rocks, but I will also be discussing some properties of fluids. Otherwise, we cannot explain that how the stability of the structures are actually controlled. Okay, so with these few things, let me show you these things. Well, suppose you are in a job, you are at a site, and you have to describe that here the rocks are like this, and well, whether the site is suitable or not, you make recommendations, and for that uh, purpose, two things are very, very important. You can measure the compressional strength, Schmidt hammer, and there are other equipment where you can measure the inside to compressive strength. You can also take samples and do it in the laboratory. And but you need to describe orientation of the rocks. And if you think about orientation, nature is actually the nature deals with two basic orientation. One is the orientation of a plane, and another one is orientation of a line. And combination of these two, you can develop all kinds of structures. The plane is not, well, it's not a plane. It can be a real plane or it can be a curved plane. Similarly, a line can be a straight line and line can be a curved line. So these four combinations will actually determine the geometry of the thing, and you have to write in your note, this is what I have seen in the field. Simple photograph will not help. So these are the professional things which are followed by all the people in the world who are doing this thing, either geology or civil engineering or whatever. I mean, who has to deal with the natural structures. Fine. So for a plane, suppose this is a plane. This is an inclined plane. So inclination can be of anything from 0 to 90 degree, whatever. But how do I describe this plane? The plane is described by three coordinates. One is called a dip. I don't know whether you have heard it. Even if you don't hear it before, doesn't matter. Basically, dip is, suppose this is the plane, sloping plane. Now the dip means the measure of the angle. Now measure of the angle means you need another plane. That plane is the horizontal plane. So the angle of this plane is this angle. The angle it makes with an imaginary horizontal plane. Now, if the angle is 0 degree, that means your plane is horizontal. If it is 5 degree, again you can say that this is almost horizontal. If the angle is 70 degree, sitting in the room, you can say, wow, this is dipping very steep, sloping stuff. So the moment you give the dip, immediately people will translate it into the situation from a distant place. And when you have these two planes, one is a real plane, it's inclined, another one is the horizontal plane. You can have a clipboard and make it horizontal, and you can measure this angle. And when you have this plane and this plane, there must be an intersection. An intersection of two planes, which are non-parallel planes, will always be a line. And this line is this. And again, suppose I tell you that the bed has a dip of 45 degree. Now you can say that, well, its inclination will be like this. But sitting in Kolkata, and if you get the information from, let's say, Darjeeling or from other parts of the world, you can never say in which direction actually is 45 degrees. Is it towards east, towards north, towards south, and in which direction? So you need a direction, and that direction is geographic direction. And this geographic direction along which the plane is sloping is called dip direction. So if it is oriented like this, the dip direction will be like this. Remember that this line, this direction is perpendicular to the line of intersection. So this is the dip direction. And what is this direction? The intersection between the two planes? This is known as strike. Now, this line has two geographic directions. And obviously, a straight line always makes 180-degree angle. So you just have to give one of the geographic directions. So you define the complete coordinates of a plane, you have to give the angle, you have to give the geographic direction along which it makes the angle, and the intersection line which is straight. Now, in this type of work or the professional work, the direction is not given in terms of northeast, southwest, southeast, because these are arbitrary things. You really cannot fix the direction precisely. It has to be, given in terms of degrees. And the international convention is this: north is taken as 0 degree, east is 90, and obviously south will be 180 and west will be 270. So if I say that the plane has an inclination of 45 degree towards 45 degree, that means the angle is 45 and the direction is in northeast direction. So this is how the direction of a plane is measured, of any kind of plane. If it is curved plane, then obviously its dip will vary. Dip direction will remain the same. Suppose this is a curved line, direction will be the same, but the amount will vary. And you have to write that the dip varies from this angle to this angle. Now, once I complete this measurement, look at this one as well. This is an alternate angle. You know this. It's very simple. This is alternate angle. Now, this angle, I really do not know that whether you are already taught the angle of repose. Hopefully, you are taught, or at least you know from your high secondary. Are you aware this angle of repose?
Yes, sir.
Okay. So, angle of repose is basically the dip of a plane at a critical condition. When if you put some substance on this, it will just start sliding. So what is known as angle of repose is basically a dip at a critical condition when a substance on this plane will tend to slide. So that is the reason why orientation of the planes and are so important, not only for measuring geological structures, but for remediation of landslide and construction of dam and etc., which I will discuss in the subsequent slide. Now, measuring this angle is a little tricky. The angle should be measured on a plane which is perpendicular to the line of intersection. Only then you will get the maximum angle. Otherwise, if you make a section like this, I will show you, it should be measured perpendicular to the strike of this layer, this angle. If you make an oblique section, still you can get an angle, but this angle will be lower than this angle. And you will be measuring a wrong angle of repose. So be very careful The angle should be measured on a plane which is perpendicular to this straight line. Fine. Now for a linear structure, it is very simple. Again, it should make a horizontal projection of that line, and the angle it makes is known as the plunge. And the direction of this horizontal projection will give you the direction. Geographic direction is known as the trend. So for linear structures, it will be plunge and trend because it has one dimension less. For a plane, this will be strike, deep, and deep direction. So this is the sequence. Fine. Now with this backdrop, I jump into some of the ductile deformation, but I can stop it for a while and take you to some other things, and then I will come back to this point. So I think the information we have just discussed and what we discussed in some of the previous classes will help us to just get an idea that what are the places where the dams can be constructed. I mean, you know that it should be across the river, but river is big, but where to construct a dam? So, I mean, instead of just telling you the points and these you will get in many literature, so I will not take that route. I will take you to a real life dam and explain that what are the consideration. And this real life dam is Masanjo Dam. I do not know whether you have seen that. That is on Mayurakshi River. That is in the state of Jharkhand, and this is the boundary between Birbhum and the Jharkhand. So this is Masanjo Dam, and this is the reservoir. Somehow it is known as Canada Dam. The reason which is given is that it was constructed in collaboration with a Canadian company, and that's why it is known as Canada Dam as well. This is a classic example what should be done. River flows in this direction, that's why the reservoir is here and the dam is here. If I take you closer to that, it's only 240 kilometers from Kolkata. And the area of the reservoir is 16,650 acres. This is a huge reservoir. Now, if I take you closer to the dam, you can what you see is this. This site is West Bengal, and this site is Masanjo. So, this is how it looks like from this side. When I was standing here and taking a photograph towards that. So you can see, this is the dam, this is the reservoir. The dam has to be anchored on solid foundations. So there are rocks here, and it is constructed like this. And there are log gates and other things. And you see huge reservoir, huge reservoir. And that reservoir is used for many purposes, tourism and fisheries and other things. So when you make a dam, basically you create an environment where it actually give opportunity to many people to earn their livelihood. So the dam is not for just construction of I mean, not meant for hydel power or fisheries and other things. There are many utilities or the reservoirs. Now on the other side, that is the downstream side. Again, I'm looking from this side of the dam. So, I mean, this is not my picture because whenever I went, I have a project over there, but I usually skip the monsoon time. And that's why, I mean, none of my visit falls during monsoon, so I have to use this picture from the Google. It's a massive dam. Its height is 150 feet, 155 feet, very high. And its length is 2100 feet, very long and high. Now, this is my picture that this is mostly winter time, and you see the rocks here. No water is coming out. This is lean period, and these are the log gates. And look at these rocks. Whenever you see rocks from a distance, you need not go close to the rock. You need not use your Schmidt hammer or other equipment. If you see the rocks is bouldery like this, rock must be very, very tough and homogeneous. Homogeneous means the rock may appear banded, but strength wise, it has nearly uniform features in all possible direction. Only then during weathering, you have this bouldery out. So, without measuring anything, you can say that these rocks are very tough, almost homogeneous in all directions. Now, look at the fractures. Some of them have fractures because of rolling, they collided, so some fractures develop. And well, the fracture develops in rocks only when they have practically no visible asymmetry in terms of strength. But somehow some weaknesses are there in the rock. So when they collide, the fractures develop during that time. But they will never develop the planar fractures, joints or other things. They will not develop. So that's why they are bouldery. Now, my question to you, you know the definition of rock. Shubir must have taught this. I have a na bolbe kintu. You have to say yes or no. Otherwise, we will be delayed. You know that rock consists of minerals, natural aggregates of minerals. Fine. In the last class, I discussed the intact rock and rock mass. Now, look at this thing. Okay. If I bound an area like this, should we consider it as an intact rock or a rock mass? Look at the cursor. It seems you didn't go through my PPTs. Maybe you are too, busy with your exam, which is natural. This part is rock mass because it has discontinuity fractures. Now, this portion, is it intact rock or rock mass? Apparently,
Intact rock.
intact rock. So, we have a rock mass where you have intact rock mass means which are visibly devoid of any fractures, any layers. I mean, weak layers. Well, you can see this layering also, but these are very tough, so you shouldn't consider in that way. So this is intact rock, this portion. Now look at this boulder. What is this portion be called? What this portion be called?
Intact rock.
Why not rock mass?
There is no fracture
Well,
or loose layer.
no, 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 no. Rock mass, you are right. I mean, your answer gives me an opportunity to explain. Rock mass is the mass of rock. It may or may not have fractures, but intact rock does should not have any fractures. Now answer. This rock, what do you say? Suppose there is no fracture. Come on, come on.
But I think it is corroded by the river stream.
Yes, but
Corrosion has been occurred.
so what? I mean, now it is a rock piece. This is rock mass, fine, because this is a mass of rock. So rock mass is fine. But can you call it intact rock?
Yeah, if there is no fracture.
Great. So whether it is intact or rock mass, it depends on the rock mass is a general term, and intact rock is a part of rock mass. But if the rock is too homogeneous, and if it doesn't contain any fractures, or maybe few, which can be ignored,
There
then the
is rocks are homogeneous.
absolutely, otherwise you would not see this boulder in nature. Well, if you go closer to this rock, you can see banding. But from the viewpoint of strength of the rock, it will not matter because both the layers are so strong that you hardly can find any anisotropy in terms of its compressive or shear strength. Even nature couldn't find. That is the reason why the weathering could only make it a bouldering. Otherwise, you would find slab-like things, and it would peel off along the plane of weakness. Even nature couldn't find the weak planes. That's why it is bouldering, and that is the reason why observation is so important. Okay, so this intact rock, rock mass, rock. So this term you should remember all the time. This is very simple. You have to just assimilate the thing. Okay, so this rock is massive granite gneiss, metamorphic rock, and this is what I said. So now the dam is constructed on this rock on both sides. That you have to believe. That you have to believe me, or you have to pay a visit there. So this entire area is made up of this type of tough rocks. And wherever you go, you see there are bouldery weathering, this side and also this side. So the first condition of making dam is it should be on the solid foundation. Solid foundation means the rock should not allow water percolation as far as possible. But not all cases we are lucky. Messenger is a rare situation where whatever you read in the textbook are found there. The rock is, unless this one is massive, and this rock has very high compressive and crushing strength. So it can take the load very nicely. So this is the section of the dam. So if I cut a section like this, the dam should appear like this. And you have the reservoir on this side, the left hand side. I showed you the reservoir. On the right hand side, this bouldery rocks. Now, when you develop this dam, first thing is it should be anchored on a massive, as strong as possible. Sometimes we are not lucky, then we have to go for the next best. Then, once you develop the dam, you encounter two basic forces. One is the weight of the dam, and second one is thrust of the river during monsoon or during the high stand of water. And you have a resultant force. And this is what matters for construction of dam. Don't ever think it will always make an acute angle with this. The reason it should be constructed in such a way that the resultant stress is a smaller angle with the load, so that how this can be achieved? If the net force is dictated by the weight, if the net force is dictated by the thrust, then it will be like this, and the dam will be destabilized. So here I just want to tell you to remember these fundamental things, that when you talk about the stability of any structure, basically we think that this should not collapse. Stability of any structure means it should not collapse. Now, collapse can occur in many ways. Some of the basic ways, first is that foundation, in case of dam, I presume that this is homogeneous and there are no constructional defects. If I consider that, then the stability of these structures will depend on whether the rock on which it is erected should not slip. Then the structure will collapse. The rock on which the load is imposed must not cross its compressive strength. Then there will be crack and this will collapse. Or, which is less likely for dam, this is important for internal structures of the dam, that the rod you use here and the load you actually give, that will not force this rod or the metallic rods bend or buckle. Even then, that will collapse. So you have to consider these three factors. Now, with these things in mind, let us try to see what are the ideal and what are the non-ideal and what are the tolerable situations for construction of a dam. Now, case one is that you have a rock which is bedded, and bedding is, bedded means layered. This is not like what I showed in the previous slide. That Masanjor is a typical good case for construction of dam. Rocks are very tough, but most of the rocks in many other dams are not that tough. And then we have case one scenario, that you have a horizontal bed. Suppose these are sedimentary rocks, or the rocks where the minerals are oriented, particularly the platy minerals like mica or talc, they are parallelly oriented, then it will be layered. Mostly, we should avoid the weak rocks for construction of dam unless you are absolutely, forced to do that. Usually the sedimentary rocks are fine, but the sedimentary rocks, in most cases, they have these horizontal layers. The moment you have the horizontal layers, the water will tend to move along this direction, unless this rock is an aquifer. Aquifer means is a rock which holds the water, doesn't allow the water to run away. I have given my notes in a note box, so don't worry about it. Just focus on my talk. So the water will seep through that, and while seeping, the water generates the force. It's a terrible force. And there are upward motion, upward thrust. It's called lift force. And the lift force basically weakens, it works against the weight. And if it works against the weight, it is bad news for the structures. It may collapse at any point of time. And continued percolation actually corrodes the rock. And again, this will destabilize these things. So when you have the layered rocks and you see the resultant force making a small angle, a small angle means dangerous because small angle means there will be a force in this direction parallel to this plane. So there is a tendency for this layer to slip along that. But if it is absolutely horizontal, well, this will not affect much. The only thing you have to ensure that the rock must not be too porous or too fissile so that a lot of water can pass through. And this seepage of water not only cause damage to the dam, this will be a loss of water. So this is our case one. So it is just so, just okay. Now, the foundation rocks are folded. For example, let's say buckle fold. Now you are on one limb of a fold. In which direction it is dipping? You see, it is dipping towards the reservoir. That's fine. The ideal situation, resultant force should be at 90 degree. And you know that from your high secondary course, if you have a plane like this, and if a force is acting only at 90 degree, there should not be any slip component because this is mg sine theta. Okay. So absolutely there should not be any slip component if the force is only perpendicular to this. But usually the force is applied like this. So it has a perpendicular component and a slip component. And in that case, ideal situation is the dam should be constructed in such a way the resultant force should be at 90 degree with this. And it should, this limb should dip towards the reservoir. Then first thing what will happen, the water cannot move up, upslope. There cannot be any seepage. And second thing, if there is no seepage, then there is no question of lift force. So it will be fine. And the entire load, of course, there is an angle is oblique with this, but effectively the force is perpendicular to this plane. Apparently, this is at an angle with this, but the resultant force, because of the thrust and the weight, the resultant force should be at 90 degree. Perfect position. No lift force, nothing. The best situation. In fact, Masanjur, the basement rocks of Masanjur is just like this. Now the third case. The dam is constructed on this limb, but now the dam is constructed on this limb. Now you see, other things remaining constant. It is sloping this side towards the downstream side, and there will be terrible seepage because the layering is just like this. Water will percolate like this, and there will be lift force. To make the situation worse, there will be slipping. There is a possibility of slipping along this plane. Look at this resultant force. Resultant force is parallel to this. The worst situation that it will only force the rock to slip. The effective load on this is practically nothing. So when you construct a dam, these are the things you should keep it in mind. The rock is not in your hand. But the height of the dam is in your hand. That will decide what will happen. If you make it little steeper than this, situation is slightly better. But the best is you must not construct a dam on this limb of a fold, or even if you don't see the limb, or if you don't see a fold, the sloping part, the sloping beds, the sloping rocks must not be parallel to the resultant force. In fact, I should say in another way that the resultant force must not be parallel to the layer junctions. In that case, you have water. Absolutely, this will slide. This will lead to sudden collapse. And this thing happens mainly during monsoon session, because during monsoon, and why the rocks are like this, even if they have a plane like this, the reason is the friction, coefficient of friction. During monsoon time, when there are a lot of water in the reservoir, then they percolate through this. So water find its way to move. They always prefer the weak zones, and these are the weak zones. And since they loosen up this part, the coefficient of friction of the rocks become lessened, and the rock actually collapses. And that is the reason why Uttarakhand and many other places, all this disaster happens for two reasons. One, the reservoir water goes up, so the resultant weight of the dam is constant. So if it goes up, the thrust will be more, and this will be just towards this. The resultant force will be like this. This is number one. And number two is, if the bed is dipping, then they will reduce the coefficient of friction along this plane, allowing that rock to slide and collapse of the dam. Sometimes what happens, you may have a massive rock, but the force of water is such that it will make a terrible impact. If it moves very close to this, let's say 10 degree or 15 degree with this, the compressive strength will just blown away. The force of the river will just make the construction collapse without any problem of the basement. So these are the things you should remember, that stability of the structure depends not only on rock mechanics but fluid mechanics as well. So these two should be taught and should be learned together. Now, using the same principle, we can choose where to make tunnels. If you have a folded layer, suppose this is a folded area. It's a small fold, but it can be regional. Some of the folds in Himalaya, actually, the wavelength of the fold is several hundred kilometers. From the satellite, you can see the folds. If you take a Google picture over Himalaya, some of the folds you will see it can be of any size. So I just give you an example. Suppose you have a fold like this. Now, what to make tunnels? Usually, people make the tunnels like this. The fold is like this. Now, making tunnels through the core of the fold is fine. Making tunnel through the rocks is always dangerous, because you are taking away the rock mass from there and making, almost vacuum. A vacuum means it's just air. And then rocks on the top and the wall would tend to cave in, because suddenly there is a release of pressure. So the high pressure material will tend to go to the low pressure side. So they have a tendency to cave in. Now, to stop this caving, you do a casing. It's cement and other construction, because tunnels you don't see that the rocks are exposed on the walls. No, there are concrete casings. But every material has a compressive strength. So it should not, the compressive strength should not be exceeded. If it exceeds, then the tunnel will collapse. Okay, and during monsoon time, the rocks will be soaked in water, and its weight will be at least 2-3 times more, and that's why many collapse of tunnel occurs during monsoon time. Now, what to do if I have to do a tunnel through that? For example, the Johor tunnel that connects the Kashmir Valley with Jammu. They are made through Pir trap, and which is a folded layer. And I am one of those lucky persons who had the opportunity to study the rocks in Panjal, that Johor tunnel in 1984. So this is a folded area and faulted area also. So they made the tunnel, and they used to spend a lot of money for the maintenance because they had to do this because that was a strategic tunnel. So you cannot have much choice. So they had to spend a lot of money on this. So usually the tunnel should not be done through the core of the fold. If you have to do it, the tunnel should be through one lane, and the direction of the tunnel will be the fold axis. I will come to this point. That the direction where two limbs of the fold actually meet, and that line is called the fold axis, and it should be done towards that so that the pressure on this tunnel is less. So these are some of the features of the rock mechanics that help you locate your construction site. Okay, so in case of faulting, well, instead of these things, you should have a fault like this, a plane like this, and you see whether it is parallel to the plane. If it is parallel to the plane, it will slip. If it is perpendicular, if the resultant force is just like this, suppose there is a fault like this, if the resultant force is like this, it is better. But again, if you have a discontinuity, a fault structures, water seepage will be the case, and well, it is not safe. You have to keep a strong visual on these things. So it's better that unless you are forced like Johor tunnel, you should not make a dam on a faulted rocks, and particularly if the deep of the fault is towards the downstream. Upstream, some compromise can be made, but not towards the downstream because the resultant force will always be towards the downstream. So these are some of the fundamental things about construction of dams, canals, and how the rock and fluid properties work together to make a structure stable or unstable. Now I will take some queries from you because then I will jump onto a small part which I showed at the beginning that I just skipped. I will go to that because you need to know the different parts of the fold, and you know that rock mechanics is a core subject for art science as well. But the purpose for which we use rock mechanics is not the same for the civil engineers. I will only touch upon that part which civil engineer will be required. I will give you the information for your repository, but I will discuss only those parts which will help you in your career. Okay, so before that, please let me know if you have any queries I have discussed so far on dam and cost and stability of dam, I should say. Well, you are too quiet. By the way, have you covered Froude number in your fluid mechanics?
No, sir.
No, sir.
I have given a little explanation in the notes for the what situation would be suitable for construction of a dam, and you will get those things in the place for notes. Uh, Let me quickly touch upon one or two things. You have studied Bernoulli's equation, isn't it? Hmm. You have studied laminar and turbulent flow.
Yes, sir.
Reynolds. Okay. So let me quickly. I don't want to get into your subject, uh, but just to put things in perspective, that the Bernoulli's I mean the Reynolds number doesn't work in an open channel. Be assured that Reynolds number only works through pipes with limited fluids. Reynolds number does not work for rivers. Well, we can describe some parameters. That's fine, because Reynolds number basically tells you the particle path. If the particle path is straight, then it is fine. This is laminar, or if it is curvilinear, then it is turbulent. I also discussed in my lectures at the beginning. But river dynamics doesn't depend only on Reynolds number. Stability of dams or other structures, the spires on the river bed, does not depend on Reynolds number. Reynolds number are uncorrected for gravity. When you have an open channels like this, means rivers, then the factors that actually control is called Froude number. The Froude number is a root over of inertial force by force of gravity. I have mentioned these things in my note. And the ultimate equation becomes V by G into D, where V is the velocity of the water, the current, the river water. G is acceleration due to gravity, and D is the depth of water. When you fix the reservoir position, the area should be deep. It should be deep for two reasons. If it is shallow, then the water will try to spread and will create humanitarian problem. And what is people are facing in the Peri Dam, Sardar Sarovar? It spreads. It has to, because you are stopping the natural flow of water, so it will spread laterally. And one more thing, if it is shallow, I mean, if the region is not deep, then if you have smaller depth of water, then the velocity of water will be terrible. This is known as supercritical fluid. For the same energy, if the depth is smaller, then the force, the thrust force will be maximum. And you know that if the thrust force varies for a given weight of a dam, the resultant force will be like this. And the moment the resulting force is not very steep, then you have a problem, lot of problems. Stability of dam, slippage of the basements, and lot of things can happen. So that is the reason why uh, the reservoir area should be as deep as possible. If you go to see Masanjur, which is a very good picnic spot, and you can see from the bridge that I have shown you in the Google map that it's hills and this river Mayurakshi moves through the valley, and this valley is that's why known as Moor Valley, Mayurakshi Valley. The river has the shape just like eye of a peacock. So please also consider this, crowd number. In your professional part, uh, if this question is asked, can we apply Reynolds number for all flowing rivers? Answer will be no. For open channels, is the Froude number in combination with Reynolds number will determine the energetics of the phase. I am sure that in your next semester or some of your semester will be taught the Froude number. But anyway, so these are some of the things which you should consider. And if you don't have any question, then I go to the unfinished part. একটু কুইকলি বলো যদি কোনো প্রশ্ন থাকে, আদারওয়াইজ আমি আগে শেষ করে নিই, দেখি তোমাদের আর কোনো প্রশ্ন আছে কিনা। Okay, so I actually showed you how the line is coordinated, and then when we go into the folds, and this fold I have already shown, the fold is the bending of layers, and this is the geometry which the geologists need it very much, but I will just tell you, I will send you a PDF, but I just discuss some of the points which you will need. That one part is the inflection point. Inflection point is the point when it's a wave, basically a wave. So many terminologies are just the terminology we use for a wave, like wavelength, amplitude, etc., etc. So some new things. One is inflection point. Well, in waves you can also consider that inflection point is the point which actually makes the crossover point. The curvature changes from this side to this side. So this is the inflection point, and if you just connect the inflection point at different points, then you get an inflection line. And then one part, this red lens, which is perpendicular to this line. This is called hinge line I was telling. The hinge line is basically when you have a fold, basically you are looking at two dipping planes. So the two dipping planes can be on same side of, like this, or can be a different side. Usually fold people perceives like this, but the fold can be just like this as well. So this is the intersection of the two planes are known as fold axis, the way we calculated the strike. And hinge point. Every point on this wave has a curvature. The curvature is maximum at this point. So this is called hinge line. I have a hinge point. And if you see the hinge point at different layers, and if you connect it and then make a plane that bisect the two limbs, then this is known as axial plane or axial surface. And the geometry of the folds, well, 3D is very difficult to draw. The geometry of the folds basically is seen on a profile section, just like the section which is chosen for measuring the deep. It's just like that. If you have the hinge line, the section should be perpendicular to the hinge line. And then this is known as the profile section. And if the hinge line is horizontal, then the profile section obviously will be vertical. But if the hinge line is vertical, Hinge lines can be horizontal, can be vertical, can be inclined, depending on how are the two limbs. And then accordingly, the profile section will change. Fine. Then, from your viewpoint, what is most important for the fold is this feature. You must have, I don't know, whether this is included in your course. Well, suppose this is a pack of layers. Okay. Now, for buckle fold, you have to put a pressure like this parallel to the layers, and it becomes like this. Okay. And it bends like this. And this is the cartoon of the stress condition at different point. To understand the stress condition, let us put some sphere on this. Now it is in the section, it is circle. Okay. Now if you compress it, the spheres will also compress, and from the shape of the sphere or in the section shape of the circle afterwards, or the shape of the ellipse, I should say, you can understand whether a particular region is undergoing extension or compression. Now, if you have this setting and you put a pressure like this, parallel to that, then it will be folded and the folds will be buckle folds. Most of the folds in nature are buckle folds. So it will be less like this. Now look at how the spheres or this circle will look like. On the outer part of the fold, it is just like this. That means if this is the initial diameter of the circle, and after folding, this diameter, this length is increased. So if you can remember the equation of strain, delta L, the delta L will be positive. So this is a zone of extension. And what about this zone? If this is the thickness, its thickness is smaller. This is the zone of compression. So in a folded layer, this will be the zone of extension and fracture will develop here, just like this. And here there are many fractures. And there will be a region, a plane in 2-dimension line. This is known as neutral surface. Any point on this neutral surface will neither show extension nor compression. This in civil engineering is called the bending. Bending can be upward or bending can be downward. And this is the neutral surface. Neutral surface means at this point, the diameter of this sphere or the circle will be exactly the same as this one. And hence, along this layer or this line, there will be zero strain. And the nature of strain on this side will be different from this side. So, if you have a folded structures in any area, do not make any dam over there because it is in the zone of extension and it is already either fractures or ready to be fractured. So little bit of water here and there or little bit of weight of this immediately will make the fracture prominent. And that is a dangerous thing. Once the fracture develops, they propagate. I discussed in stress strain curve. Just always remember the Titanic episode. Immediately it will tend to split like this. The way the Titanic crashed. Just like this. Suddenly it will collapse. So be very, very careful. The geometry of the folds. Do not do it here. It's better to do it here because this is the zone of compression. It's denser. So if you have to make a dam, you will make the dam here. It's thin form type of thing, not here. And when you blend some metals, you also see the same thing. Now, why this thing happens? Suppose this is the sphere, the section. Now we put stress like this, and you turn this circle into an ellipse. So along this direction, there will be elongation. Along this direction, there will be compression. Why compression? Because initial length was this, and now the length is like this. But length has reduced. So there will be the density will increase and the thickness will decrease along this. And that is what happened. And here there will be elongation. Now look at the intersection of this ellipse and the circle. Along these two lines, there is no difference between the ellipse and the circle. If you calculate the strain along this line, delta L will be zero. Because initially it was like this. Sorry, I mean, I did a bad drawing. I mean, it should be from here to here. I will change it or you can do it. So along this, delta L will be zero. Along this, delta L will be zero. So that is the reason why this neutral surface is developed. It doesn't develop just like this. It develops because of this. So whenever you deal with faults, be very careful. Now the obvious question is, should we avoid the hinge all the time? Answer is, well, if this is the fault, then you should. But there are different geometries of folds, which, well, I am giving you the literature. Actually, fold is classified on the basis of its geometry. Geometry has different viewpoint, and this is the relative orientation of a line and plane. And we have different shapes. And this is something very interesting for you. This is the full classification of the basis of interlimb angle. That is the angle between the two limbs. So how open these two limbs are. So if it is slightly, angle is very large, and it is gentle, then open, then tight to isoclinal. Now isoclinal means you see the angle is so small that you will see as if both the limbs are dipping in one direction. And if this be the case, then the hinge will be in the direction of compression. Limb will be in the direction of extension. And you should not make any structure on this because this is extending. But you can think of using uh, construction on this hinge. But it's better to avoid because if it is too sharp, there are other problems as well. But what I want to mean that hinge means extension, zone of extension. This is not right. It depends on what is the interlimb angle of the folds. And same is true for your materials, bending of rods or bending of anything. If it is just like this, then it will not be in the field of extension. Extension will be along this. So these are some of the things which I will give you the information and you can do it yourself. Okay, so these are some of the things I thought I should discuss with you today. Now I conclude my talk. Now you can ask some question to me if you wish. Let me tell you one thing, Froude number, you have to study for your own interest. If you are required for, you know, organization which makes dams or bridges on big rivers, they would certainly ask you this question, that whether Reynolds number can describe the stability. So this is for your interest, whether that is in syllabus or not, whether Prof has taught you these things or not, but you have to get your job. You have to study this thing. Very similar to Reynolds number. The only thing you have to replace this, frictional forces with the force of gravity is mg, and then you cancel out the terms. The only thing, this will be in a root, and you can come up with this equation of Froude number. If you are interested about tsunami, why tsunami is so devastating? For tsunami, the Froude number is 1. If the Froude number is 1, it is known as critical fate. If the Froude number is less than 1 means gravity is in the denominator. Inertial force is always in the numerator. Okay, so it is in the denominator. So Froude number less than 1 means gravity has more role to play. So gravity is just like weight of the dam. So if the F is less than 1, then the fluid cannot cause any harm. You can simply test it. Suppose there is a flow, okay, and slowly flowing water. You put a pencil or something like that, or a dip your finger. You'll see the waves will move in this direction. So the wave will move in the upstream direction. Flow is coming from here to here, very gently moving. You dip your finger, you'll see that the wave moves in this side. So the wave will move upstream side. Flow of water will be quiet, otherwise this will never happen. Now you increase the velocity, it moves very fast. So dip your fingers, you'll find that waves is in this direction. This is known as supercritical fluid, greater than 1. Supercritical fluid means inertial force dominates. F equals to 1. Critical fluids, wave will move at the same speed of the water. And tsunami is just like this, it is critical. And it moves like bullet. When you see it, you cannot run away because it moves at the same velocity with the fluid. And that is the reason why tsunami can cause so much of harm. Of course, for rivers, you don't have to bother about tsunamis. But well, some structures can be built on the sea coast for many reasons. So it has to be considered while making those things. And all on a sudden, the thrust force will increase. And if the thrust force will increase, the resultant force will be like this. And if the resultant force is like this, then you will try to topple the structures, and the structures will collapse. So you should construct it such a way that for all eventualities, it should not cross this 45-degree line. The resultant force. If the resultant force crosses 45 degrees, then the structure will be vulnerable, will a little bit of thrust, it will just up. So this is simple things, and, and we are done. Sometimes we are not lucky, then you have to tell people that well, this cannot be constructed because of that. Otherwise, if the dam is collapsed or allowed to collapse, then there will be thousands and thousands of people will die because the water will be supercritical to critical and they will move like bullets, just wash away the people from both sides. And don't allow the dam side to be clogged with synthetic materials. Most of the dams are tourist places, and you know what happens in the tourist places. We throw garbages, plastics, and everything. They actually clog reservoirs. People don't do picnic on the side where there is no water. No, all the picnic spots are on the bank of the reservoir. And so they throw everything there. And one of the reasons for that Uttarakhand disaster was shallowing of the reservoir. So when the cloud burst, the reservoir could not accommodate the water, and the water moved like bullet, and the thrust force increased. The resultant force was just near horizontal. It's just collapsed the dam. The dam was collapsed, and a lot of people died, and everything happened within few minutes. Just like Titanic, it's bang crack because it is an instantaneous train. Cracks. So please remember these things. It's not for getting marks. It's a very interesting thing. It will be very useful for your future. Okay, thank you very much. তোমাদের যদি কিছু থাকে দু একটা বলো, আমারও ভালো লাগলো যে তোমরা ইউ ইন্টারঅ্যাক্টেড উইথ মি। এটা কপি করে নিন। Seems
So dams are actually made with some regulations that the pressure should be with certain limit, but when the flood comes, then how can that withstand that pressure? Or
actually
without overflowing, there can be a huge pressure if a huge amount of water affects the dam at a time. So then,
well,
without overflowing, a huge thrust can come.
yeah, actually that's a good question. I tell you, I mean, during monsoon, you must have seen in the newspaper every time that whoever is in the power in West Bengal government, in the first, this is the story of DVC, and every time there is a pressure on the DVC that don't release water. As a politician, as a chief minister, I can always tell that. Because if you release water, then the water is going to flood the regions. So I may say, "Oh, don't release." But for a technical person, we know the danger of doing so. If you do that, if you don't allow the water to pass through the log gate, if you close the log gate, then it will be dangerous. It will make the dam collapse. And then people will not get time to run away. So there are, before releasing water, they sound caution at least one day before or at least several hours before so that people can run away. If there is a natural disaster, if and the dam collapses, they will be simply washed away. So, as a sensible citizen, it is our duty to convince people that if you stay nearby, you should, save your life first. Number one. The second part of your question, that whether we can predict, sorry, we cannot predict. What we can do, we can study the history of monsoon for last many years. That is what we can do. And make a plan considering the worst will happen again. That is what we can do. In the Uttarakhand, before the Uttarakhand disaster, everybody knew, everybody means the technical persons knew that there will be cloudburst. Cloudburst is nothing, the cloud doesn't burst. Basically, what happens, first a huge pile of clouds develop. The difference between rain and clouds is that clouds, the water occurs as tiny, tiny droplets, very small droplets, which cannot form a sufficiently large drop so that it can be attracted by the gravity. And when this happens, we call it rain. Now it piles up, piles up, piles up. At one point of time, the activation energy of nucleation is crossed. The moment that crossed, immediately entire cloud is converted to rain, and there will be torrential rain. And we call it cloud burst. There is nothing to burst. The clouds are not in high pressure. That's a non-technical term. There is no bursting. Bursting means things must be in high pressure. And pressure release is called bursting. The violent pressure release is called bursting. The cloud doesn't burst. It is not in high pressure. So basically, the nucleation occurs, and growth occurs. Suddenly, huge rain comes down, and this is something that can be predicted. If you go to the NASA side, the NASA gave the warning 3 days before that there is a huge cloud being piled over there, and this is the region where it can happen. Well, they couldn't save the dam in any way. It's not possible, because if you really go for all kinds of precaution, then amount of money will be fabulous, and that one has to consider as well. So what they could do, they could keep the people to safer places. Then there would not have been much loss of lives. Property would be lost under any circumstances. If this kind of disaster occurs, uh, or calamity occurs, well, you cannot do it. So similarly, we really cannot predict. What we can only do, that we can take the precaution and study the monsoon patterns for the last 50, 60 years. And we be prepared for the highest level of water that was recorded or expected, and go for our constructions. That is what we can do. But nature is really tricky. Something cannot be predicted. Well, these are accidents, so we cannot do anything. But if we could predict something and we do not take any measure, then that is unpardonable. So Uttarakhand dam collapse is not in the hands of people. It could collapse in any case. Nobody could stop it. Nobody in the world could stop it. But what we could do, to take the people to proper shelters. Any other questions? You must have heard there are a lot of trouble that China is increasing the height of the dams. And the height of the dam is really dangerous. If that collapse, then a huge pile of water will move and fraud number will be alarmingly high. Alarmingly high. The water will behave like the tsunami water. It will just sweep away whatever they find on the way. Any other question? আচ্ছা তোমরা কি টায়ার্ড হয়ে যাচ্ছ পড়তে পড়তে? sometimes that happens. I mean, I passed through your stage that too many examination and other things sometimes works against the mind, and it creates a negative feeling in the mind, so you don't feel like listening to anything. I understand that, and I'm trying my best to use photographs and other things so that it can be make as much as possible. I mean, make interesting as much as possible for me. Anyway, তোমাদের যদি কোনো প্রশ্ন থাকে আমাকে লিখেও জানাতে পারো। If you have any question, you can shoot me mail, and I'll be happy to respond. So, in that case, email you shoot me a mail telling the date of examination. So I will change things. But I tell you one thing, the question I have set, you have to think. Very simple question, but you have to think. You will not find answer anywhere in the material I have supplied in my PPT. Just you think what it should be. Answer should be brief and to the point. And your phrasing should be accurate. If the answer is brief, every word will count. Okay? So please be careful in phrasing your answer. For example, if I ask that a bed is dipping 45 degrees towards north, and the water of the river or the river flows to the south, do you think that the area will be suitable for construction of the dam? Justify your answer. Then you have to discuss these things. Or if I say that I want to construct a dam on the river Godavari, you know that the Godavari flows towards southeast direction. The Indian shield, India, from the southern part, I mean, excluding the Himalayan region, we call it peninsular India. So this peninsular India are dipping in two directions. General dip is in two directions. Of course, there are hills and other things, but there are dips in two directions. Can you tell me what are the two directions? Is it north-south, east-west? Suppose I set you this question here. What will be your answer? And if I add another question, in which side the dip will be steeper.
Sir, west to east.
West to east means that is one direction. Dip direction is one, either east or west. I said that in two directions.
Sir, I want to say that our Arabian side, Arabian sea side is higher and Bay of Bengal side is lower. Godavari River. Or
So actually, so you are saying that the general tilt is towards east and towards west, or
east,
south
east, east, east.
east and no west.
No, sir, you are saying Godavari River.
No, no. I said that, well, that was my first question. The second question was the peninsular India has or dips in two directions. Then what are these two directions? It's towards north, towards south, towards east, towards west, towards northeast, towards northwest. The two
No,
directions.
sir, there is no certain direction. There are many mountains. Like there are Narmada River, which is going to Arabian Sea, and there are Godavari River, which is going to Bay of Bengal. No any certain direction.
That is the answer. India and peninsular India tilts in two directions, and one is towards east and another is towards the west, and that's why all the big rivers actually either flow towards east or flow towards west. But now answer the second question. Thank you very much. Then answer the second question. Then which side deep is steeper, western or eastern?
Sir, Eastern.
Right?
Because, sir, in the Arabian side, there is Mohisan. I cannot say the term. I don't know the term, but there are very deep seaports like Mumbai, Kochi.
Hmm. But sea is sea, but rivers is river. Rivers has its identity so long it moves over the land.
No, no, sir, no, sir. Your question was that which side is steeper means
Peninsular
which side.
India, deep steeper. Peninsular India, that is the land part. Deep steeper. Your first part is okay. That it dips towards east and it dips towards west. Because the rivers are either flowing towards west or flowing towards east. Because water always follows the dip. This is the property of fluid. Water always follow the true dip. Water doesn't follow apparent dip. It's always follow the true dip. That is the maximum inclination direction. So when you make, I mean, this is the problem with the, bathroom. I mean, construction of bathroom. You cannot make a 45-degree angle, then people will sleep. So the deep is hardly 2 degree, 3 degree, and to keep the 2-3 degree is a difficult task. And I do not know how these people, without knowing science, they maintain this thing. Most of the cases they cannot maintain, and that's why you have the problem of water clogging. Okay, water should not clog. So if there is a gradient, then they should flow like this. So it is the property of the fluid to follow the deep direction. So your first part is okay. That some rivers is flowing towards west, so there must be a dip towards west. There are some rivers which flowing towards east, so there must be a dip towards east. Fine. But answer my next question. In which side this dip is more? And that means you have a potato like this. Now either this will be like this or this will be like this.
Sir, answer of the second question is the western side is more deeper because there is no any
Deeper is not
delta.
deeper. Beta. So it's not deeper, it's DIP. It's not deep. The ocean can be deep, but it is the deep of the surface which the river follows. River doesn't know what is the depth of ocean. River doesn't know unless it meets. How does it know? It doesn't know. It only knows the slope of the surface over which it is flowing.
Yes,
So
sir.
all the big rivers are either flowing towards east or flowing towards west. So definitely the peninsular India must be dipping this side as well as this side. Otherwise the river would not flow in that direction. Then it moved to the south. But my question is in which direction? Well, you are taking it so seriously. Array, most of the rivers are flowing to the east. Only three rivers are flowing to the Arabian Sea. Mahi, Narmada, and
And a Kerala
Sindhu.
river.
ah,
Sindhu is Pakistani.
no,
Indian
Sindhu
river.
is a different. Tapti.
No, sir. Sindhu is flowing toward south.
Array, Sindhu is a dead river. Not to the south. Actually, it originates in Manas Sarovar. Okay, so it flows towards Pakistan, and discharges water there. In many parts, the Sindhu is it moves below the ground. So, so
So
these are
there
the
is a
three.
river in Kerala which is flowing in Araman, which
Small
is
rivers are there.
ends in Arabian Sea.
There are several small rivers, riverlets. They are flowing. I'm talking about the big rivers, and most of the big rivers are all along the eastern coast. Ganges, then you have Narmada, Brahmani, Kaveri, Narmada. So all the big rivers are flowing towards it. So the deep is more towards that, and that's why most of the rivers flow in this direction. So I mean, this is the principle we use when the rocks appear to be horizontal, and your eyes cannot really identify in which direction it is dipping. Then the best thing is put some water on that and see in which direction water is flowing, and that will give you the true dip direction. And you have to measure, you orient your compass accordingly. This is a big problem for us, particularly the site engineers or site geologists. Sometimes it is very, very tricky that we don't identify the slope. Then we have to drop water and see in which direction it flows. And that is the direction of the deep direction. So this is something which you should answer. I mean, not everything should be told or talked. These are the general principles. Hmm. Okay, thank you very much. Or if you have any questions, you can ask. Otherwise, I will be closing within 2 3 minutes. You are also tired. Today is Sunday, but still, I'm thankful to you that you joined my class on Sunday. Actually, I will need one class more. I will not put much stress on you, and I will discuss a few things. Uh, then I'll be done. And for all of you, if you need me for any future references, don't hesitate to get back to me. You are my students. So for any requirement, if you think that I can help you, you can contact me. Okay? Even after the class. Don't think that the class is over, so our relation with sir is snap. No, no, no. I don't believe in that. And I hope that you also don't believe in this. And just for your information, mm, uh, I am not too sure whether you are aware of the master's programs in Europe. There are a lot of possibilities. If you want to do your master's course or PhD course, there are a lot of opportunities in Germany, in France, in Netherlands. If you think you can go through some of the things, they are the DAAD. You can go to the DAAD website and you can watch out the opportunities. There are a lot of opportunities, PhD, masters, and these things, and they have very reputed institutes. Well, US is always there, but the education in Germany and France is top. So, if you think that you should try abroad, just watch out EAAD site, New Delhi. Okay, thank you very much. হ্যাঁ তাহলে আমাকে একটা মেল লিখে দিও সৌভিক ঠিক আছে বাবা অল দ্য বেস্ট থ্যাংক ইউ বাবা
Thank you, sir.
Thank you,
ভালো
sir.
থাকো বাবা। হ্যাঁ ভালো থাকো বাবা হ্যাঁ বি হ্যাপি